All right, here is the last recording. Okay, here's our last task for the day, thinking about where we would find the solution to when a square root function is equal to another function, this one a linear function. And we can actually do these both graphically and algebraically, but today we'll look at how to graph and then solve. So the first step was to graph the linear function using slope and y-intercept. This is a review of Algebra 1 stuff that you've been doing since forever. There's our y-intercept. Our slope is 1 over 2, which means the y changes 1 when the x changes 2. So we can go up 1 and then to the right 2, and then up 1 and to the right 2 again, up 1 and to the right. And we can really do this as much as we want. We can go backwards. What we see forming here is a nice linear function connecting all the points, and we've got a straight line that continues in both directions. Then our next task is to graph the radical function. So I see here that there is no shift left or right. It's just square root of x. There's no square root of x with a plus or minus under the radical. So there's no left or right shift. All there is that vertical shift up 3. So up 1, 2, 3, we have our first point. There's already a point there. Actually, you know what I'll do is I'll change the color here. That might be easier to see. I'll graph the square root function in red. So our first point will be up 3, no left or right shift. I see no stretch, so that means this will follow the typical pattern of up 1 over 1, up 1 over 1, 2, 3, up 1 over 1, 2, 3, 4, 5, and then I'm out of room. So you can see the red dots forming the curve that is our square root function, and we can see where they've conveniently overlapped with the linear function. So our solutions occur here when x is 0. And again, this is interesting, when x equals 4. So in fact, this particular line and square root function have two solutions, two places where they intersect. Tomorrow when we look at this, we'll see what happens when we solve them algebraically.